multiplying and dividing rational expressions in Algebra 2. So now we're going to start to multiply big fractions and divide big fractions with polynomials on them. This is when the factoring really comes into play. So this first part, we're just going to talk about simplifying them first. In order to simplify these fractions, you need to have the same thing on the top and the same thing on the bottom in order to cancel them out. You are not allowed to just pick from each, so I can't just pick those x's. So in order to see what I can cancel out, I have to end up factoring both of them. So looking at the top, I see that 3x minus 12 has a GCF of 3. So that means my GCF goes to the outside, and after I do my division, I'm left with x minus 4. And then I'm going to have to look to factor the bottom. The bottom does not have a GCF, so I need to look to play my game. So is there something that multiplies to a negative 8 but adds to a negative 2? Yes, negative 4 and positive 2. And since nothing is in front of x squared, these become my factors of x minus 4 and x plus 2. Now that I have factored everything, I look to see, is there anything exactly the same that I can cancel out? In this case, yes, I have an x minus 4 and an x minus 4. I can cancel them out because they are exactly the same. One is on the top of the fraction and one is on the bottom. So then I'm left with 3 on the top over x plus 2. And that would be my final answer. Now let's look at number 2. So I have x plus 2 on the top. Now again, I'm not allowed to just cancel out 2's. They are not the same. You have to factor everything first before you cancel. So on the top, I'm left with x plus 2. There's no GCF, and there's nothing to factor on the top. So I know the top of my fraction is going to be x plus 2. Now 2x squared plus 3x minus 2, that needs to be factored. There's no GCF, so I have to play my game. So I have to go 2 times negative 2, which is negative 4. Now, what multiplies to negative 4 but adds to a positive 3? That gives me positive 4 and negative 1. I cannot use my trick here, so I have to use my shortcut. And if you remember, I can go x plus 4 and x minus 1, but I have to divide by that first number of 2. So if I divide both parts by 2, this leaves me with x plus 4 divided by 2 is 2, so it gives me x plus 2. And then negative 1 divided by 2, well, that leaves me with a fraction, so I take this 2 and move it to the front, which gives me 2x minus 1. Now again, things have to be exactly the same, so I have x plus 2 on the top and x plus 2 on the bottom. I can cancel them out. So top of my fraction, I'm left with a 1. Bottom of my fraction, I'm left with 2x minus 1. Now we're getting into multiplying them. So these first two, notice that there are no plus or minus signs. So we're going to multiply them and simplify them a different way than what we do with 3 and 4. So when we have no plus or minus signs, we can actually just multiply straight across like we do with fractions. So top times top, I'm left with 6 times 2, which is 12. X to the 4th times x is x to the 5th. Y times y to the 4th is y to the 5th. And then the bottom, 5 times 4 is 20. X times x to the 3rd is x to the 4th. Y squared times y is y to the 3rd. Then we can simplify. So 12 divided by 20. Again, we can go to our calculator and we can type 12 divided by 20, enter, then math, enter, enter, 3 over 5. So in my new fraction, I'm going to have 3 over 5. Then I have x to the 5th divided by x to the 4th. So we say 5 minus 4 is x, which stays on the top because 5 is bigger than 4. Same with the y's. 5 minus 3 is 2, so y squared stays on the top. And there's my answer. So if you want to pause the video, try number 2, you can do that, or I'm going to work this one through as well. So number 2, again, there are no plus or minus signs, so I can just multiply straight across. 7 times 2 is 14. X times x squared is x to the 3rd, and then we just have y. Over the bottom, 3 times 1 is 3. X squared times x to the 3rd is x to the 5th. Y to the 4th times y is y to the 5th. So again, start with your numbers. 14 divided by 3. Go to my calculator. 14 divided by 3. Fraction, math, enter, enter. It stays as 14 divided by 3. So 14 over 3. Then I have x to the 3rd over x to the 5th. Subtract, I get 2. And I want to write it in the bottom because 5 is bigger than 3. And then we have 1 and 5, which gives me y to the 4th on the bottom. And that's my answer. And now let's look at problems 3 and 4, where we do have addition and subtraction signs. So 3, believe it or not, we are actually multiplying two fractions because x plus 1 is over 1. Now when we have plus and minus signs, we don't want to multiply straight across. We're actually just going to start by factoring everything. So starting with the top of the first one, I have x plus 1. There's nothing to factor, so I'm going to put it in parentheses, x plus 1, and that's over the number 1, which again has nothing to factor, times, now looking at the top here, x squared plus 3x minus 4. I'm going to factor that. So what multiplies to negative 4 but adds to a positive 3, positive 4, and negative 1. So the top of my fraction becomes x plus 4 and x minus 1. I can do that because there's nothing in front of the x squared. Then I look at the bottom and I need to factor that. So here I'm looking for what multiplies to a positive 4 and adds to a positive 5. Positive 4 and positive 1. So this gives me x plus 4 and x plus 1. Then I look to see what can cancel out. Again, they have to be exactly the same. One has to be on the top, one has to be on the bottom. So I notice my x plus 4's cancel, and my x plus 1's, because that's on the top and this is on the bottom. It doesn't matter if you pull from different fractions, as long as it's on the top and on the bottom. So that leaves me with x minus 1 on the top over 1, which we just write as x minus 1. So number 4 is similar. If you want to pause the video and try that on your own, you can. Otherwise, I'm going to keep going. So x plus 3, we put that over 1 because we are dealing with two fractions. And then I'm looking to factor. So there's nothing to factor with x plus 3, so that leaves it as x plus 3 over 1 times, so again I'm going to factor x squared minus 3x minus 10. So what multiplies to a negative 10 but adds to a negative 3? Negative 5 and positive 2. So x minus 5 and x plus 2. over, and here I'm going to factor the bottom. So the first thing I see is a 3 in the front of the x squared. Whenever I have a number in front of x squared, it makes factoring a little harder. So I'm going to look to see, is there a GCF? Can I divide all of these by that number 3? In this case, I can. So if I take the 3 out, that leaves me with x squared plus 4x plus 3. Well, now inside in blue, that has made my factoring a little bit easier. So here, I'm now going to factor my x squared plus 4x plus 3. So what multiplies to 3 but adds to 4? 3 and 1. So now I'm going to rewrite everything. I have x plus 3 over 1 times x minus 5 and x plus 2 on the top over my GCF of 3 and then my factors of x plus 3 and x plus 1. So now everything is completely factored. I can look to cancel things out. So my x plus 3's cancel, and that's it. So I am left with, on the top, I have x minus 5 and x plus 2 over, I don't need to write this 1, but I do need to write the 3 and then my x plus 1. And you can leave it in this form. You don't need to multiply everything else back out. 5 and 6 are a little bit different, but the process is the same. Here we have two fractions where we do have to factor everything. So this is going to be a lot of factoring. So looking at the top of number 5, x squared minus 6x minus 7. No GCF, so I play my game. So I'm trying to think what multiplies to negative 7 but adds to a negative 6, negative 7, and positive 1. So on the top, that now gives me x minus 7 and x plus 1 over, here I have x squared minus 16. Now I notice I'm subtracting two terms. They are both perfect squares, so this will give me my difference of squares of x plus 4 and x minus 4 times, I'm looking at x squared minus 5x plus 4. So what multiplies to a positive 4 but adds to a negative 5, negative 1, and negative 4. So that gives me x minus 1 and x minus 4 over x squared plus 3x plus 2. What multiplies to 2 but adds to 3, 2, and 1, which is x plus 2 and x plus 1. Now I realize that was fast, so if you need to, rewind the video and pause it so you can see where I'm getting these numbers from. And remember, Unit 2 is where we first learned factoring if you need to rewatch a video. So now that everything is factored, I'm looking to see what I can cancel. Remember, I have to be exactly the same, one on the top, one on the bottom. So x minus 7 is on the top. There is no x minus 7 on the bottom. X plus 1 on the top, and I do have an x plus 1 on the bottom. X minus 1, nothing on the bottom, x minus 4, and x minus 4. So then I am left with parentheses x minus 7 and parentheses x minus 1 on the top, and then parentheses x plus 4 and x plus 2 on the bottom. And that's my answer. So again, for number 6, you can pause it and try it on your own, or I am going to walk through this one as well. So this is another one where I need to factor everything. So I'm starting with x squared minus 9. I notice it's two terms subtracting, and they are both perfect squares. So that factors to x plus 3 and x minus 3 over on the bottom x squared plus 5x plus 6. So what multiplies to 6 but adds to 5? Here I can do 3 times 2 because 3 plus 2 gives me 5. So that's x plus 3 and x plus 2 times we have x squared minus 4x minus 5. So what multiplies to negative 5 and adds to a negative 4, negative 5, and positive 1. So that becomes x minus 5 and x plus 1 over, and then the bottom. So what multiplies to 12 but adds to negative 7? And that would be negative 4 and negative 3. So it's really important that you know your multiplication tables, but again, you can always use your calculator to find the factors. So the bottom is x minus 4 and x minus 3. So now that everything's factored, we go to cancel. I have x plus 3's top and bottom. I have x minus 3's top and bottom. And that's it. That leaves me with x minus 5 and x plus 1 over x plus 2 and x minus 4. Remember, that's all the canceling that we can do because they have to be exactly the same in order to cancel. Now, if you flip the page, we talk about dividing. Now, with dividing, there is a phrase that you want to remember, and that phrase is keep, change, flip. Because we always want to try and get everything back to multiplication. So keep, change, flip. So with number 1, again, it is 2 fractions because that's over 1. So the keep goes with this first fraction. I'm going to keep that the same. X squared plus 5x plus 6 over 1. Change is changing the division to multiplication. And then flip is you flip the second fraction. So we have x plus 5 on the top over x squared plus 4x plus 3 on the bottom. Now that we are back to multiplication, we can go back to what we were doing with factoring and canceling everything out. So the top, what multiplies to 6 but adds to 5, is 3 and 2. So that becomes x plus 3 and x plus 2 over 1. Multiplication, so times, there's nothing to factor with x plus 5, over. Now the bottom over here, what multiplies to 3 but adds to 4, 3 times 1, so that gives me x plus 3 and x plus 1. And then I can cancel. So my x plus 3's cancel, and I'm left with x plus 2 and x plus 5 on the top, over. I don't need to write the number 1, and then x plus 1 on the bottom. We're going to go through another example. Remember, whenever you see division, keep, change, flip. So keep the first one, x squared plus 13x plus 42 over x squared minus 1. Change to multiplication, flip the second. So x squared plus x minus 2 over x squared plus 10x plus 21. Again, if you need to pause and you want to practice the factoring on your own, you can do that. I am going to go through factoring these fractions, but I am going to go kind of quick. So, top one, I'm looking what multiplies to 42, but adds to 13. And those two numbers are 6 and 7. So that becomes x plus 6 times x plus 7 over, the bottom is a difference of squares. It's two terms subtracting, and they're both perfect squares. So it becomes x plus 1 times x minus 1. Multiplying, top of the second one, I'm looking for what multiplies to negative 2, but adds to a positive 1. That is positive 2 and negative 1. So that gives me x plus 2 and x minus 1 over the bottom, what multiplies to 21 but adds to 10, 7 and 3. So it gives me x plus 7 and x plus 3. So now that everything is factored, I look to cancel, which I see x plus 7's cancel, x minus 1's cancel, and that's it. So I'm left with x plus 6 and x plus 2 over x plus 1 and x plus 3. So that is how we're going to simplify, multiply, and divide these rational equations. It is heavy in factoring. Again, go and review the Unit 2 factoring video if you need additional help, or come see me.